Well, good afternoon, everybody, and welcome along to Data Platform Downunder for the month of September. My name's Warwick Rudd. I'm your host, as well as my co-presenter, or co-host, I should say, Martin Catherall. This month, we've got Mini Walia joining us from Microsoft, who's going to take us through unlock real-time insights and take instant action with MS Fabric Real-Time Intelligence. This session is being recorded, and we will put it up onto the Data Platform Downunder YouTube channel after today's session. If you haven't already signed up and joined our YouTube channel, we will put it in the chat where you can join up. Therefore, you can come back and watch this session as well as any other sessions that we've had over the last couple of years. If you do have any questions, feel free, put them in the chat. Martin and I will be monitoring that. We'll be able to ask Mini those questions for you. Try and make this as interactive as possible, or raise your hand and we'll come back and we'll get you to ask your question. Now, before I do move on and hand over to Mini for today's session, I do want to call out, there's a couple of upcoming events that you may be interested in. So next month on October 11, we've got Data Saturday Melbourne down in Melbourne occurring. Registrations are available for you to sign up, come along to the event. I believe there's going to be 3 tracks for the day. So great day of learning where you can learn from some pretty good speakers on all things data platform. If you're not able to go down to Melbourne, in November, we've got Data Virtualized for November edition. So this is on Saturday, November 8th. It is a virtualized event for attendees. The speakers are in person, where we get together as speakers to collaborate, and then we present for you. Registrations are available for that as well. So sign up, another free day of learning. So that's got 6 sessions, very targeted sessions, but a great day of learning. This is the second event for the year for Data Virtualized. So with that, I'd like to hand over to Mini, and we'll get this month's session running.
Cheers.
Awesome. Thank you so much, Warwick. Let me share my screen. Can you all see my screen?
Yes, we can.
Awesome. First of all, thank you so much, Warwick and Martin, for having me here. Great to see you all, those who have joined the session. My name is Mini Walia. I'm a program manager on Microsoft Fabric Customer Advisory Team. We call it as a CAT team. It's part of the Fabric product group. And I lead real-time intelligence workload within the Fabric CAT team. And I'm responsible for the APAC region for all the real-time intelligence opportunities. And that's what I'm going to talk about as part of today's session, that how RTI, which is the short form for real-time intelligence, how RTI is changing the world of data analytics. Before I get started, can I have a quick raise of hand to understand how many of you worked on Fabric or real-time intelligence, or just explored it, or how many of you are completely new to the world of Fabric? Quick raise of hand, those who, if people can give thumbs up if they have, okay. All right, so it looks like a lot of people have already explored Fabric, not new to Fabric. So we'll get started. That's a good sign. So I don't need to set more context on the Fabric side of things. All right. So before we dive into what exactly real-time intelligence is, what features it provides, I want to touch on why real-time intelligence is important and why should you care, and how does it really impact our day-to-day life. So a couple of examples, as you see in these photos, I'll talk about some of those. Grocery shopping is very common to everyone. We see a lot of cameras, RFID devices that are deployed in the retail stores, and they are mainly collecting continuously the data to figure out which stocks are going to be low or out of stock, so you don't end up seeing empty shelves in these stores. Another example of the real-time analytics scenario. We all love to travel. At airports, we want to understand any changes in our flight schedules or any gate changes. Those are the scenarios. We want to collect our baggages as soon as possible without waiting for hours in the queues. So these are some of the scenarios, and same way, all the devices we use in our day-to-day life, be it mobile phones or the EV vehicles we drive, all of these, they get manufactured in some factories. So building those connected factory scenarios, these are all some of the scenarios in our day-to-day life where if we don't process data in real time, it loses its relevance. So when I talk to customers, these are some of the most commonly asked questions by majority of the customers and users. They want to know as soon as anything changes within their applications. Every customer wants to get continuous granular insights from across their ecosystem. And the most important one, which you all I'm sure would have heard, is every company wants to become a frontier firm. They want to build a solid foundation for their agentic AI solutions. Now, on this point, I want to spend some time. Um, if we think about it, what's the point of investing heavily in building agentic AI solutions if your AI agents are giving you stale information? So that's where tapping into the data in real time is way more important to build that solid foundation for your agentic AI solution. So when you are talking to an agent, it has got insights or from the fresh, up-to-date information. So those are some of the scenarios why real-time intelligence is so critical in today's world where we are capturing humongous amounts of data from whatever devices we use in our day-to-day life, be it homes or at work or outside. So every customer, every user wants to be proactive in their approach. They don't want to be reactive. So all of these scenarios customers want to cater to, but why they are not able to do that today? Because this is what the tech landscape looks like. As you can see, it's quite fragmented. And if you need to build the real-time analytics solution, end-to-end real-time analytics solution, you need to do integrations across too many diverse components, and it becomes quite tedious, complex solution, time consuming, and of course, very expensive. These are all the problems that Fabric real-time intelligence is trying to solve. With Fabric, as you all know, it's our unified SaaS solution for building end-to-end data platforms, and real-time intelligence is one of the core workloads within Fabric that gives you the ability to build end-to-end real-time analytics solutions. And the foundation of Fabric, as you all know, is your data is always stored on one lake. You have got single copy of your data, be it the data that's stored within Fabric, or you can also tap into the data that's stored outside of Fabric in form of shortcuts. So always it's just a single copy of data, be it the natively stored or in the form of a shortcut. So those are the capabilities real-time intelligence also leverages to give you that end-to-end real-time insights view. So you can not only get real-time insights, you can also take actions on top of your data in real time. Now, these are the core capabilities, or I would say core features that real-time intelligence provides. As you can see on the left side, there are a lot of natively supported connectors, which you can use to ingest data in a seamless way. These are all no-code, low-code connectors that help you to ingest data, as well as you can also do the transformations within Event Stream in a no-code, low-code way. Event Stream is the name of the service that provides all these capabilities for ingestion and transformation in a no-code, low-code way. And also it has capabilities to build the pro code scenarios if at all you are coming from heavy engineering background. So if you want to, for example, write some complex transformation logic using SQL or Spark code, that is also very much supported within Event Stream. Event House is our real-time analytics database that has got native time series analytics features, geospatial analytics, AI ML capabilities. So it's a columnar store, fully distributed, and gives you heaps of native features. But the way it stores data, it automatically indexes every column that gets ingested and compresses the data automatically, creates the compression of the data. That's how you get that price performance ratio with this engine. Also, we have got the capabilities to build the digital view of your physical world. Digital Twin Builder is that capability we announced this year, and it's part of the RTI family now. And you can build your, of course, real-time analytics dashboards. Either you use the real-time analytics dashboards that are natively provided within RTI, or you can use Power BI as well. And the most important one is not only ingesting, processing, and visualizing data. We have a service called as Activator that gives you the ability to take actions on top of your data in real time. And those actions could be in form of Teams messages, emails, or you can also trigger any third-party workflows. Across all these capabilities, the 6 capabilities you see on the top, they all have AI baked into it in form of Copilot, which helps you to convert your natural language prompts into queries or real-time dashboards, or you can use Data Agent as your virtual assistant, and a lot of other capabilities are there. I'll show you as we move forward with some of the demos and a couple of other scenarios. Real-Time Hub is a unified catalog for all of your assets. So you can easily discover what all streaming assets you have. You can do the governance, and it's much easier to subscribe to all the events and rest of the RTI ecosystem. It becomes the starting point for RTI. And a lot of customers I talked to, they mentioned that RTI Fabric is new to the industry, so is RTI. So this is just to give you an idea that although the service is new to the industry, but the underlying services and engine had been there for more than a decade. So as you can see on this slide, RTI is a combination of Azure streaming, messaging, and analytics services. On top of that, we have developed new capabilities like OneLake, Activator, and all the AI features that are baked into the platform. So combination of all the services that are mentioned in the first 3 boxes, it gives you the fully integrated no-code, low-code SaaS solution. In terms of scale, again, this is just to give you an idea. The underlying services and engine are already operating at a massive scale. We are processing more than 10 exabytes of data per month. Petabyte scale ingestions we are doing on a daily basis, and billions of queries are being processed and run by this platform. So when it comes to a scale, it's a tried and tested, proven platform. In terms of use cases, as you can see on this slide, RTI has got use cases across industry verticals. So for example, starting from the automotive industry, these are some of the commonly used use cases I've listed here. There are a lot more. So for example, in the automotive industry, a lot of customers, they build the connected fleet management solution to understand, for example, how the different vehicles are operating, collecting telemetry from the vehicles to understand the rotation of the tires, engine, speed of the vehicle, so they can track the vehicle, monitor the vehicle in real time, and can suggest any route optimizations if needed. In the manufacturing space, uh, customers typically use it for predictive maintenance scenarios wherein they set thresholds, for example, the temperature, humidity for equipments or sensors that they use in the manufacturing plants to understand if the values are going beyond certain thresholds, then it can shoot off the alerts and notifications, and you can take actions in a proactive manner. Similarly, we have got customers in the logistics space to monitor and track the delivery of the parcels. Same thing applies for the energy and utility space, where customers bring in the data from different energy meters to understand if any failure monitoring scenarios or power station monitoring scenarios. Across all these industries, there is a horizontal use case that you see on the bottom, which applies to every industry vertical. That is around building end-to-end observability scenario. So, as I mentioned, the engine that is running underneath Event House, the roots of that engine is in the time series analytics space, and that's how customers use it for real-time monitoring and audit compliance or security forensic requirements for building this logs analytics solution. So typically these days when I talk to customers, cost optimization is one of the key things top of mind for every customer. So they want to offload the processing of the different types of logs from their SIM solutions and other platforms and network logs, and that's one of the commonly used pattern for RTI. These are some of the customers from those who have given us permission to use their logos or to talk about their stories publicly. So, for example, Emirates is using RTI for tracking the flight schedules, gate changes schedules, so they can avoid any kind of congestion scenarios at the airports. Same way, Apollo Hospitals in the is one of the largest healthcare company. They are using RTI for tracking the patient journey history to understand how patient when they got admitted, how their history went for auditing and tracking purposes, and they also use it for real-time distribution of the lab reports. So there are a lot of use cases they are building on. Locally within APAC, I would say Melbourne Airport is using for the similar scenario what Emirates is using it for tracking the flight schedules and any changes in the gates or other weather changes impacting the flight schedules. One New Zealand is another customer within APAC, which is using RTI for call center analytics scenarios. They have reduced the call center's support call wait times using RTI. They have built the operational monitoring dashboards to understand which calls are taking longer so they can shuffle the staff and reduce the call wait times. And the One New Zealand story is publicly available as well if at all anyone wants to go and look into the details. This is one of the fastest growing workload in Fabric. So the service went GA last year in November. We already have got more than 9,000 customers globally. So you can see the growth. It is one of the fastest growing, and we feel really proud of this workload growing so fast. I'll take a pause here. If at all, any questions on the chat, or Warwick, if you see anything on
No,
the
no
chat
questions.
windows.
No questions so far on chat, and nobody's raised their hand. So everybody, just remember, make sure that take advantage of this. It doesn't come around all that often, so ask the questions, and the more interactive it is, the better it'll be for you.
Anyone, any questions so far, or any comments, thoughts? All right. 3 seconds rule. I'll talk about one customer story a bit more before I dive into the architecture patterns. Uh, Hanwha Q Cells is one of the largest solar panel manufacturing company globally. They are using RTI heavily. They have built a virtual power plant use case using RTI. So this was their previous architecture, which was built using all the open source and some of the AWS technologies. The feedback we got from customer was it was becoming a nightmare for them from the development and maintenance perspective because there were so many different diverse components. They needed a lot of diverse skill sets to maintain them, and they were seeing um, uh, longer duration needed, like time to release the new features was also growing day by day with this architecture. So they wanted to simplify this one. They simplified using RTI. So as you can see in this architecture, they ingested data from the different IoT devices, sensors, APIs into RTI, and they were using APIs on top of the event house to connect to their custom fleet management application. So the fleet management application was doing all the complex calculations in regards to how much energy, for example, was generated by the solar panels, how much was sent back to the grid, all those complex calculations in real time were done on top of event house. So this is what the virtual power plant scenario they built. And this is the feedback from the customer. They were with us on stage at Microsoft Ignite this year, Microsoft Build this year in May, and they shared why they are investing heavily on RTI. Number one was the ease of use. They could increase the time to market by 30% because of the no code, low code capabilities. The development cycle was reduced significantly, and they love the speed of RTI. So the scalability, they have got massive 3,000, 4,000 sites across the globe, and they could ingest the data pretty easily and get the sub-second latency in terms of the operational monitoring dashboards they have created, and 40% reduction in the operational overheads and 25% reduction in the licensing costs. So these are the numbers shared by the customer, and I would highly encourage, if you go on YouTube, you will be able to see from the last year, November, also Emirates was with us on stage, and a couple of Johnson's Controls also shared their numbers and savings. So these are the stats that are encouraging more and more customers to get onboarded onto the platform. Now, I'll talk about some of the architecture patterns. Again, there are so many different architecture patterns customers are building, but I'll talk about some of the commonly used ones. And if anyone has got specific scenario, I can probably pull the relevant architecture. But one of the core strengths of RTI is in terms of building event-driven architectures. So as you can see on the top, the traditional batch ingestion scenarios where we used to do traditionally pull data at a certain cadence, could be 15 minutes, hourly basis or daily basis. Now, RTI gives you the ability to build the architecture in a push mode. So as soon as anything changes in your landscape, rather than waiting for the batch cadence to trigger and run, it automatically triggers the pipeline, for example, CDC scenarios. So any changes in your operational databases, it triggers the pipeline. So you can then tap into that data in form of real-time dashboards, or you can use agentic AI solutions with all the fresh and up-to-date information, or you can trigger alerts and workflows using that information. So this is a high-level view of event-driven approach that RTI enables you to build. I'll talk about the detailed architecture of this event-driven approach, how you can build in terms of the tech components. So as you can see in this architecture, you can ingest data in the streaming or batch mode. Event Stream, as I mentioned, has got the native connectors which you can use to ingest the data. It could be different types of events, or there could be slowly changing reference data that you can ingest via Fabric pipelines, which is similar to the Azure Data Factory. So you ingest that data into Event House, or the reference data can be stored on Lakehouse. The beauty of this architecture is you don't need to move data from Lakehouse to Event House. You can use shortcuts to query on top of the events data that is stored on Event House. So within your dashboards, you can combine, mix and match the data, events or telemetry data with the reference data. And within Event House also, you can build the layered architecture, which we call it as a medallion architecture, wherein you can land your data onto the bronze layer and do the processing and parsing of the data using update policies, or you can also do the parsing and processing using no-code features within event stream. So there's a lot of flexibility in the architecture. And finally, you can build your pre-aggregated materialized views that can be consumed by your Power BI reports or real-time dashboards, or the way I showed in the Hanwha Q-Cells case, wherein you can also leverage APIs to connect with your custom applications. And Activator is the service which is integrated across this whole pipeline. So you can shoot off alerts either when the stream is ingesting in, for example, in the FSI space, customers use it for fraud detection scenarios, or you can write your own queries to set the thresholds and conditions to decide when to raise the alerts, or it could be on the top of your dashboards. So as I mentioned, the alerts can be different types. You can have Teams message, emails, or it is natively integrated with Power Automate. And that gives you the ability to, I hope everyone knows about Power Automate. It has got natively supported hundreds of connectors. You can send SMS or trigger any third-party workflows or ServiceNow tickets. So heaps of scenarios it opens as part of the Power Automate integration. In terms of the AI features, there are lots of features. I'll probably spend more time on this towards the end. So as I said, Copilot is one of the capability to convert your natural language prompts to KQL queries. You can use different types of agentic AI solutions. We have got Data Agent, which is sort of a virtual chat assistant for you can directly chat with your data. So the idea is you don't really need to build pre-canned dashboards and reports for every scenario unless you know that business is going to use it. This is in fact something Gartner also shared in one of their reports, that majority of the data projects, they fail because we over-engineer and we create heaps and heaps of reports, which business, they don't even end up using those. So that's where wherever we have got the absolute necessity of building reports, better to build those. And otherwise, you can very well use these agentic AI solutions to directly chat with your data. So any kind of ad hoc questions business has, they can get direct answers. Hello?
I mean, yeah, looks like we lost you just for a little bit and then you came back.
Oh, okay. Sorry about that. Looks like
That's
there's
okay.
some glitch in the internet. Is my screen already shared? Everything?
Yeah, so we're still on the event-driven data architecture slide.
Right. Okay. So, any questions on the chat? I'm just checking.
Okay, so we've got two. You briefly touched on this, but we've got, I believe you can use change data capture as a real-time source. If that's correct, are you seeing customers move from batch data using CDC to real-time ingestion via CDC?
Great question. Yes, absolutely. So as you can see on the left-hand side, we have got so many operational databases, CDC as a source, natively supported, different flavors of SQL database, Postgres, Cosmos DB, and few others. So yes, a lot of customers, rather than using that batch approach, they are using the CDC approach to build the event-driven architecture. So they don't need to wait for the batch to run. They can get notified as soon as anything changes.
Excellent. And then the other one on the previous slides where
Hope
you were
that
talking
answers your question, Mark.
while Martin's typing away.
Okay.
We've got a second one. So on the earlier slides where you were referencing customers and Melbourne Airport as a case study, Ray would be interested if there is any links available to read up on those if they're towards the end of the slide, or if not, we can put them in the chat.
Yeah, definitely. I'll share the links, but if you will go and search online Melbourne Airport and Fabric Real-Time Intelligence, you should be able to find it. I'll also share after this call. So Melbourne Airport, One New Zealand, their case studies are there you go. Darren has shared. Thank you so much.
Okay. So with that, I think we can continue.
Awesome. Okay. So sorry about the glitch. And I was explaining about this architecture. Hope you folks heard till uh, the integration of the activator part. And the another bit I wanted to touch on was the ability to build and train ML models. That is, I would say, although there is ability, you can do that within RTI as well, but we have seen customers prefer to use the tools of their choice. It could be Azure Machine Learning Services, Fabric Data Science, or different flavors of Spark customers can use to build and train their ML models, and then they can export their ML model as a pickle file into Event House for the real-time inferencing scenarios. So that's pretty much about this event-driven architecture approach. I'll move on to the next pattern, unless if anyone has got any questions on this architecture, I'll take a pause. Otherwise, I'll move on to the next one.
Going. Gone.
Okay. All right. So the event-driven approach we talked about that applies to different industry verticals, and the observability, end-to-end observability scenario that you can build using RTI. You can ingest data from different kinds of sources, and it could be different types of logs, could be platform, application logs, or it could be different scenarios. As I said, one of the scenario is around cost optimization of the end-to-end observability stack. Likes of the SIM solution, customers use Splunk, Sentinel, and a lot of other solutions, which are, I would say, this is the feedback I've been hearing from the customers. They end up using those solutions in a wrong way by ingesting all types of logs to their SIM solution, and that makes it atrociously expensive. So to optimize those solutions, they try to use SIM solutions only for the critical security logs, and rest all logs, they build the hybrid solution with RTI by sending the data through the RTI stack. So you can see these are all natively supported ways in the observability space. So you can ingest data from OpenTelemetry. We have got the native connector to Event House. A lot of people from the SQL background are here. There's a SQL Watcher solution that has also got the native connector to Event House. Same way you can use Event Stream has got native connectors to Azure Monitor Logs, or the ServiceNow events can also be sent directly to RTI. So this is one of the other patterns which is very popular and commonly used by the customers. All right, so this is pretty much the about the architecture patterns I want to talk about. Anything, any specific scenario, anyone is using any um, tools or products that they would like to hear about how to integrate with them, or um, I can see a lot of people are typing. Let me know if you would want to unmute yourself and ask your questions, or I'll move on with the next section. All right, so let me talk about the AI features within RTI. I already touched on some of those. So Copilot is the first basic foundational feature that gives you lots of native capabilities and to transform your natural language prompts to queries and real-time dashboards. We talked about data agent as your virtual assistant. I'll show you a demo as well. Operational agent is a new capability we are introducing. It's currently in private preview. This is like, think of it like a virtual, onboarding a virtual team member within your team to whom you can assign tasks, and it can automatically monitor your whole ecosystem and can highlight any issues, and also it can take actions on your behalf. So this is coming up very soon. Next week at FabCon, we are going to make the announcement around it. It's going to be a game changer, I would say, which automatically does a lot of things in terms of monitoring customers' overall landscape. And the last one is around the MCP server support. If at all customers have got advanced scenarios, you are none of the natively supported agents don't work for your scenario, you have got full flexibility. RTI stack is very well supported on the MCP server, so you can build your own custom solution using that. It's available publicly as well on our GitHub repo. You can just download the RTI MCP server and you'll be good to go to build your own agentic AI solution. With that, I will move on to the demo section. Till the time I'm switching gears, if anyone has got any questions, let me know. All right, so in regards to the demo, I'll talk about a scenario that we have built with the data simulated from the thermostat sensors. Think of a scenario, there is a commercial building which has got multiple commercial sensors from which the data is being ingested. And I'm monitoring the humidity and temperature of those sensors to understand what should be what requires any kind of maintenance or any thresholds going beyond the certain limits. So for that, first of all, let's start with just a simple view. If I want to understand, I've built different components within that: event stream, event house, and data agent and activator. I'm going to show you all of those. So the first step would be, if I want to understand the lineage for this real-time dashboard, how this was built, it clearly shows you that it was the data was ingested via event stream into a KQL database, which is part of the event house. One event house can have multiple KQL databases, and then the real-time dashboard was built on top of it. You can navigate from here as well, but I've got all the screens open just for making it easy and quick for the demo purposes. All right, so this is the event stream canvas. So here you can see I'm ingesting data from the natively supported Event Hub connector. And then I'm on top of, you can preview the data here. You can see what's being ingested. We also support multiple schemas now. So for example, you could have, I've got just one source. You can have multiple data sources here. And within your stream, you can define different schemas. So it can automatically help you to bifurcate that to whichever destination or scenarios you would want to split that. Now, in this case, what I'm doing is I'm doing transformations in a no-code, low-code way, doing the data type conversions. And I'll show you one more capability within the transformations. So as part of that, so for example, the stream that I showed you that has got the JSON payload within that, I'll probably switch to, and if I add a field over here, you can see there is a telemetry. When you expand, it shows you the battery level, humidity, and temperature. These are the JSON attributes that I'm getting from the Event Hub as a source. I'll show you the uh, JSON payload that is coming as part of the stream. So this is just a very small example of how easy it is to do the development within this no-code, low-code environment, wherein you don't need to write complex ETL logic to parse and process your JSON payloads, or which could have complex nested arrays as well. Sorry, looks like there's something wrong with my internet connection today. I'm working from home, so it's been very slow. So once it, okay, there you go. So here you can see this is the telemetry column that I was showing you. This is a small, simple JSON payload, and without writing any code, it was showing me the three attributes within the event stream, so I can select which one I want to pass to my database, for example. So this stream I'm sending to a KQL database, and here I'm directly connecting it to the activator to shoot off any alerts. And I'll edit this to show you the different sources. These are all natively supported connectors, not only Azure services, we also support natively the connectors for GCP and AWS. So you can configure all of these. There's no coding required. And regarding the transformations, you can filter data, join, aggregate, or you can write custom code using SQL and Spark as well. Spark is going to light up very soon here, post FabCon. And the different destinations we support are given here. So you can use Event House, even Lake House as a destination, or for any real-time inferencing or alerting scenarios, you can use Activator here as well. This is about event stream. I'll move on to the next one. So this is the one of the operational monitoring dashboard on the thermostat sensor data that I've built. Here you can see you can easily, these are all natively supported features in terms of aggregating hourly average humidity for a specific device, the device ID that I've selected here, time range, all of these capabilities are natively supported. You don't really need to code for them. Now, as part of this, I'll show you the auto refresh capability just to demonstrate the speed at which it runs. So I have configured the auto refresh as continuous. So you can see as soon as data is landing in the database, the numbers and graphs, everything is changing. So this is one of the operational monitoring capability. To be honest, none of the customers don't typically use continuous refresh. They use at certain seconds or minutes. So that could be one of the scenarios, but just wanted to let you know how fast this service is. And here you can see the anomaly detection capability that is also natively supported. It can highlight any outliers in your data. Here in this case, it is highlighting anomalies in the temperature of the selected device. This is the data agent capability. Please feel free to stop me in between if you have any questions on any of the scenarios. Otherwise, I'm moving on to the next bits. So data agent, as I said, is a simple way. Just with 2 clicks, I configured this is going to be my source. I've selected the table, and then you can start shooting off any natural language prompts and interact with the agent. So for example, here I'm asking, can you find the device with the maximum temperature over the last 2 days? It gives you the answer, not only the answer, it gives you the rationale as well, why it provided this answer, all the explanation as well as the query. So this is how you can easily interact with the data. And as part of the data agent, you can also provide AI instructions if at all needed. You want to refine the results of the agent. So prompt engineering can be done pretty easily. You can provide example queries to the agent to improve the results if needed. And another thing I want to mention is Data Agent is fully integrated with the Azure AI ecosystem. So for example, you can use Copilot Studio to connect with the data agent as well. And Azure AI Foundry, all the Azure AI stack is fully integrated with the Fabric AI features. This is the before I talk about this one, let's have a look at the Event House. This is the homepage of Event House, where you can see it shows you all the overview in regards to the user's activity, what happened, the over the last week, and who are the top contributors. Within this Event House, I've got these 6 databases. I'm going to move on to the thermostats database, which has got all the sensors data. You can see clearly the ingestions happening. So if at all there are some issues with the ingestions, you can clearly look over here, or you can configure alerts if no data is getting ingested over a certain period. That can be shown here. And you can see the compression ratio. 2.9 GB of data compressed to 18.2 GB. So these are some of the features that make it price performant compared to rest of the products in the market, I would say. Now, within Event House, you can, like, for example, here I've got all the layered architecture that I was showing you. The data is landing into the staging raw table, and then I've created the update policy for transformation to build the bronze layer, which is this thermostats table. And then on top of that, I've created a couple of materialized views, which is your gold layer that can be consumed directly by your Power BI reports or real-time dashboards. You can see here, whatever queries you run, you can save those queries as a dashboard. This is the real-time dashboard experience. Just keep on pinning your queries and you'll be good to go with your real-time dashboard, or you can create a Power BI report, or you can also set an alert on top of these queries, wherein you can define on every condition what action to take. Now, another capability that I wanted to show you was you can also run SQL. This is a KQL language. You can also run SQL from Event House, and you can also use explain operator to convert your SQL queries to KQL queries if needed. And the best friend for all the engineers these days is Copilot. That is also very well supported. So if I go to Copilot here, I can say, can you find average temperature of devices over last 1 day in 5 minutes bucket? So it generates that time series analytics query for you. Even anomaly detection in all the advanced scenarios, it can generate those queries pretty well. Now I'll switch on to the activator view, how activator is giving you the no code, low code experience. So the same alerting experience that I was showing you, that is being configured here, where I'm getting the battery level stream. On top of that, I'm configuring the conditions. So for example, these are all the no code, low code capabilities, where you can define, for example, no presence of data or any state changes. Here I'm saying, if at all battery level is greater than 100, don't shoot off alert on one occurrence. When it has been true for 2 hours or certain duration, then only send me an email alert. and you can configure over here, could be Teams, ICM ticket, or if I say new custom action, this is where you can go and directly connect to the Power Automate experience. If I do this, copy, you can click open. This directly opens up the Power Automate canvas wherein you will get that stream. Oops, looks like I need to sign in separately on that one. The window was open for a while, probably that's why. But this is how you can natively move from your Fabric to a Power Automate world, and it's gonna take the stream of events into the Power Automate so you can shoot off any alerts or trigger any third-party pipelines. That's pretty much what I wanted to share and talk about. Let me know if any questions, thoughts, comments from anyone.
Okay. If you've got any questions, now's the time to either put your hand up, put them in the chat, take advantage. So while you have a think about that, thank you, Millie. This was fantastic, especially the demo, being able to take us through the different scenarios. That gives you a good indication as to what type of things it can be used for. With the time series one that you were showing before, and you changed the refresh timing, does that have any impact on a cost utilization on the frequency that you are pulling the data?
Absolutely, yes. So if you're running queries at 1 hour interval versus 1 second interval, it's gonna add up to the cost. More queries you fire, more CUs you are going to consume. But I hope everyone knows how the Fabric capacity pricing model is. It's a capacity-based model. Once you provision a Fabric capacity, you can use any of the workloads within that. And we don't really penalize customers for running more queries, but depending on the size of the cluster you are on, it's going to consume more CUs, of course, if you refresh at a faster rate, to answer your question.
And just taking that just a tiny bit further around the CUs, is there a starting point of CUs that you need to be on to use some of these features? So, for example, when Copilot first came out, we had to be on a 64 CU or higher, and that went away back in April, down to a 2 CU. With any of this, is there any starting points that people need to know about? I.e., I need to start on a CU8, for example, to be able to do X, Y, and Z.
There are no minimum CUs, or I would say the Fabric capacity limits that you need to start with. You can start with F2 as well, but typically I've seen customers and community folks, those who have built operational monitoring, these kind of dashboards on the simulated data, F4 is a good starting point, I would say, so that your demo runs well. You can show that continuous changes on your dashboard as well.
Excellent. Martin, you've got a question.
Yeah, I was just wondering, Manny, having looked at KQL a bit, it seems like fairly straightforward when you got pretty basic queries, but it does scale up quite a bit. I think like the learning curve seems to be, I don't know, how would you rate the learning curve for KQL compared to SQL for someone who maybe knows SQL reasonably well?
Yeah, see, again, my opinion, I would say, you might think it's biased, but this is the feedback I'm sharing, what I've heard from the customers, typically for techies who are pro in SQL or any programming language. KQL is super easy to pick up. Plus, with all the capabilities I showed you in form of Copilot and virtual data agent, you can get your queries, even if there are some things here and there. I would say that you still need to look at the results of the query, and manual validation is definitely required, whatever you get from Copilot. but that gives you a really good starting point. So for example, if you see this query, it's super simple where I'm just filtering the data where NQ time, this is a time column, ago last 1 day, and aggregating the data, summarizing it by the device ID and binning into 5 minutes bucket. You can do n number of changes on this. So once you start using KQL, you yourself will feel it's way more intuitive and super easy to pick up. So it's just yeah. I haven't really heard much concerns from the customers on the language side of things. The concerns that I typically hear are where most of the folks, they feel, hey, I don't have any streaming scenarios, so RTI is not for me. That's where I need to burst the myth, telling them that RTI is not only for streaming scenarios, it's mainly gives you the capability for building event-driven approach. So cadence is doesn't matter at what cadence your ecosystem is getting any updates or changes. And that's where RTI shines. A lot of customers are using it for scenarios where files land on OneLake or ADLS Gen 2 at few minutes cadence, and the moment file lands, it automatically triggers ingestion. So these are the strengths and capabilities of RTI, I would say, which most of the people they miss.
Yeah. All right. Nice one, Minnie. Thank you very much.
No problem.
We've got a couple of minutes left. Anybody else got any questions at all that they would like to ask of Minnie? So while people are thinking about that, Minnie, given what you've just said about it's not just for streaming. So, for example, somebody could design use mirroring from Azure SQL Database or managed instance, given that that's supported, or even the new one that's in public preview at the moment with going from SQL Server. You could mirror that, and given that that's going to go straight to Fabric, then utilize the analytical endpoints that you've got access to use this and grab that data and put RTI over the top of a traditional OLTP workload.
Absolutely, yes. So there are a lot of patterns. I was just looking for the mirroring one you mentioned. I don't seem to have here, but yes, you're absolutely right. You can use it for by mirroring the data from different ecosystems. It could be, for example, a lot of customers use it in combination with Snowflake. So Snowflake is their data warehouse. You can either mirror or shortcut from Snowflake. They use RTI as a hot or warm layer as part of their Lambda architecture, and Snowflake as the cold layer as their data warehouse. So there could be similar way, lot of different patterns you can use to leverage the speed of the platform.
And for those of you who haven't played with the mirroring side of things, don't think that it's what the old school database mirroring that we had pre-2012. But not only are the technologies that I mentioned, but there's also the open source one where you can go, I want to mirror and create my own, which go out and, like we can see here, we could go out and pull data from PostgreSQL, for example. So lots to think about from that side of things. Got a couple of statements. Okay, so we've got an RTI workshop running in Melbourne that we can sign up for. Martin has put that in the chat, so if you are interested, have a look at those. Feel free. Another way of keeping up to date and learning, and it's also running in Sydney. So for those of you who are in Melbourne or Sydney, take advantage of those. We've got some comments about RTI being underrated. Thank you, Heidi. And some feedback on great session. Thank you, Minnie. So for everybody, a big thank you to Minnie for giving up her time, coming along to Data Platform Downunder, taking us through RTI in Fabric and how you can use it and what type of things you should start to think about. The link about the Melbourne Airport, Ray, hopefully that's helpful for you to be able to go away, have a look, and look at how that was used. As mentioned at the start of the session, this session has been recorded. Once we have finished, we'll process that. We will look at getting it up onto the YouTube channel as quickly as we can. If you aren't a member, then feel free. I have put the link for the YouTube channel in the chat. Feel free, sign up there. You'll get notified when we do upload sessions like this. Come back and watch this session or any other session that we have hosted. Stay tuned for our session that we're going to upload and schedule for next month. But before we do finish, we have got a question. So Simon, if you want to either put it in chat or unmute yourself, feel free.
It was an accident. That was great.
Okay.
Thanks.
Okay.
Thank you so much, Warwick and Martin, for having me here. It was great, and folks, feel free to reach out to me on LinkedIn or otherwise if at all anyone has any questions. But this was great.
Okay. Thank you, everybody.
Nice one, Minnie. Thanks a lot, everyone. See you next month.
Thanks all.
Thank you. Appreciate it.
Thanks.
Bye.
Thank you.